So for the second problem here, you do have to read it a little bit carefully. I'll skip the beginning and just go straight to determine the size and direction of the net magnetic field at location P. So it is a problem involving the two parallel wires that you had in the previous problem. But in this case, you have a stupid cat. You have a point P that is below those two wires, and you want the magnetic field at that point. So you're not looking for force. So that cancels out any equation that has force. There's no moving charges in here. What you have is two current carrying wires, and you have and you want to find a magnetic field based on the distance from those two wires. So let's take a quick look at what we have up here. So we have force is not important, no charges, don't care about forces, don't care about forces. For this equation, we do have two current carrying wires, but we're not looking for forces. We have no turns of a solenoid, so this value right here, no turns, not important. We're going to be working with this right here, the strength of a magnetic field, the permeability of free space, our 2 pi constant, current, and distance. Now we have two wires, which just means we'll use this equation twice. I'll try to write on the screen. Mu over 2 pi I over d equals your magnetic field. So first of all, it says net magnetic field. So we do have to kind of consider whether or not these magnetic fields are adding together or subtracting from each other. But you have the wire number 1, which is 5 amps. It is 15 centimeters, 0.15 meters above wire 2, and then the point is 0.04 centimeters above wire 2. So the 5 amps is this distance away from point P, and you can figure out the strength of the magnetic field. You'll do the same thing for the 3 amp wire, and that ought to take care of you for the second problem. We'll move on to the third problem. So for this third problem, now we are looking at the strength of a magnetic field. I'm sorry, the force, magnitude of the force on wire 1 due to the interaction of those magnetic fields. So we're looking at a force. There's always that permeability of free space number. The two currents, the distance apart they are, and the length that they're interacting. Over here, these wires have those magnetic fields swirling around them, but the only place that they're interacting, my screen's jumpy, is over this area right here. So we're just going to work through and determine the force that those two wires are pulling against each other. Okay? Good luck.